What's up, guys? It's Miss Altman here. In this last video for this week, we will be reviewing how to graph linear inequalities and what it means to be a part of a solution set. So make sure you have a pencil, some paper to take notes, because you're definitely going to want to write some things down so you can refer back to it as you're doing your weekly assignment and your weekly quiz. Now, first thing that you're going to want to write down is this particular chart. It's going to help you understand what type of line to use whenever you're graphing a linear inequality and where to shade, either it being below or above the graph. So I'm going to jot that down right now, and I'll explain it as soon as I get it written down here. Alright, so what this particular chart means, you want to be sure that you pause this and you write this down, because you're going to definitely need it. What this means is after you plot your points of your linear inequality, you have to look at your particular inequality symbol in your problem to determine if you're going to be using a solid or dashed line, or if you're going to shade above or below the graph. So what that means is, if you're going to be using a solid line, your inequality symbol is going to be less than or equal to, or greater than or equal to. So this or equal to sign right here in less than or equal to, or this or equal to sign in greater than or equal to, is going to determine if you're going to be using a solid line whenever you graph it. If that solid line underneath your less than or greater than symbol is not there, then you're going to be using a dashed line. So if your symbol is just greater than or equal, if your symbol is just greater than or just less than, then you are going to be using a dashed line. Now, how you read it from this way is, if your symbol is less than or equal to or just less than, you're going to shade below the graph. Remember, if it's less than, go below. If it's less than. If it's greater than or equal to or greater than, in these bottom boxes right here, then you're going to shade above the graph. You will see some examples as I go along in this video, but you want to be sure that you have this chart written down, because you're definitely going to need it. Another thing that you're going to need for this particular assignment this week is Mr. Slope Man. Something that we have gone over in class. I'm going to go over it again for you right here. Let me get it written down for you, and then I will explain it. Mr. Slope Man. Okay, so what Mr. Slope Man is basically saying is that if you have a positive slope, your graph is going to take this shape right here. If you have a negative slope, your graph is going to look something like this red line. If your slope is undefined, you're going to have a vertical line down the y-axis. And if your slope is equal to 0, you're going to have a horizontal line across the x-axis. Make sure you jot down Mr. Slope Guy. Make sure you jot him down. Again, if you have a positive slope, your graph should look something like this. If you have a negative slope, your graph should look something like this red line. If your slope is undefined, you're going to have a vertical line that crosses the x-axis. And if you have a slope that equals 0, you're going to have a horizontal line that crosses the y-axis. Alright, so let's just dive right into an inequality that's already solved for y. Because remember, if the inequality is not solved for y, you have to solve it for y using cross method. But let's say we already have an inequality. Y is greater than or equal to negative 3x plus 4. It's already solved for y, so it is ready to be graphed. This particular one is ready to be graphed. Now, I'm going to go ahead and just draw a little coordinate plane here for us. Remember, we have our x-axis right here, and we have our y-axis right here. So if you look at our inequality right here, it looks very similar to slope-intercept form. And if you remember, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So in our problem up top, our slope is going to be -3 because it's the number that's paired with the x. If you look at slope-intercept form at the bottom, the slope is paired with the x right here. So in our original problem, -3 would be our slope, and our y-intercept is going to be a +4. This is going to be our y-intercept. So what does that mean, y-intercept? Well, it's going to be the point that this particular graph crosses the y-axis. I'm sorry, let me make one change to the problem. This problem is supposed to be y is greater than or equal to. So let me add that line right there for or equal to. Okay, so let's go back to me talking about the y-intercept. The y-intercept is going to be the point that the graph crosses the y-axis. So if I have a y-intercept of a +4, I'm going to go to the middle of my coordinate plane and I'm going to count up 4. 1, 2, 3, 4. I counted up 4 blocks and I'm going to put a point there. Now, you want to go back to your slope, and we see that we have a, let me get some space here. We see that we have a negative slope. Our slope is going to be -3. Well, what's another way that we can show slope? If you guys remember, we talked about it in class. Another way to depict slope, especially on graphs, is rise over run. So what that means is that if you just have a whole number, in this case we do, just -3. We have a whole number, -3. Our rise is going to be 3. And our run will be 1. We can always assume that if we have a whole number, it's being divided by 1. So that's how we can make a whole number into a fraction, by dividing it by 1. So our rise will be 3. Our run will be 1. You cannot forget that we have a negative slope. So if you remember Mr. Slope Guy, you know that your graph is going to look something like this red line right here. It's going to look something like that. So if I have a rise of 3, I'm going to always go up 3. When you rise, you want to go up on the y-axis. Always go up 3, and if it's negative, you want to go to the left towards negative numbers on the x-axis. Let me explain it on the graph right here. So to graph my slope, I'm going to go up 3 spots from my y-intercept, start at the point, that red point, and count up 3 spots. 1, 2, 3. And since it's negative, I'm going to go to the left 1 space and put a point there. Now, since I went up 3 and to the left 1, I can do the exact same thing, so I can make my graph longer, but I'm just going to do it opposite. If I go down 3, I have to go to the right 1, do the exact opposite. So I'm going to start at my y-intercept, and I'm going to count down 3. 1, 2, 3, and then I'm going to do the opposite. I'm not going to go to the left 1, I'm going to go to the right 1, and I'm going to put a point there. Okay. Now, from there, you can look at your symbol in your original problem. It's greater than or equal to. So because of that or equal to sign, we know that we're going to be using a solid line to connect our dots. So you can go ahead and connect your dots now. It's not going to be perfect. It's okay. Go ahead and connect your dots now with a solid line. And since it's greater than, we know that we're going to be shading the area above the graph. So that means anything above this graph. So let me explain to you what it means whenever you shade an area. So the shaded area on this particular graph means that I can pick any ordered pair in that shaded area and it will give me a true statement. If it gives you a true statement, then it is a part of the solution set of that particular problem. So let me show you exactly what I mean. If you guys remember, we talked about test points. That's exactly what we're going to be doing here. Test points, where we're going to be substituting an x and a y value to see if our inequality will give us a true statement. So in this shaded area, I'm just going to pick a random point. Let's say I want to pick this point right here. So this point is going to be a +1, 2, 3. It's going to be a +3 and 1, 2, 3. +3. 3 on the x, 3 on the y. So I have a test point of 3 and 3. Now what that means is I'm going to take my original inequality, y is greater than or equal to negative 3x plus 4. And I have a test point of a positive 3 for my x and a test point of a positive 3 for my y. So wherever I see a y, I'm going to substitute my positive 3 test point. And wherever I see an x, I'm going to substitute my positive 3 for my x test point. So instead of writing y, I'm going to write positive 3 is greater than or equal to negative 3 times, instead of writing x, I'm going to substitute it for my test point, which is going to be a positive 3, plus 4. Now I'm just going to solve this inequality out to see if it gives me a true statement. So I'm left with 3 is greater than or equal to, okay, give me 1 second, it's not going to let me write it right there, so let me write it down here. 3 is greater than or equal to, a negative 3 times 3 will give you a negative 9 plus 4. I'm still left with 3 is greater than or equal to, still not going to let me write it right here. 3 is greater than or equal to, I am having some technical difficulties. 3 is greater than or equal to, a negative 9 plus 4 will give you a negative 5. Is this a true statement? Is 3 bigger than a negative 5? Well, yeah, that's definitely true. So this just proved that I can pick any point in the shaded area up here, and it's going to produce a true statement if I substitute the values. So let's say I pick a point that's outside of the shaded area. What's going to happen if I do the exact same thing I did with the point I picked in the shaded area? So let's pick another test point, and let's pick one outside of the shaded area, and let's see what happens. So I am going to pick the point right here, which will be a negative 1, positive 2. So now I have a test point of negative 1, positive 2, and in my original problem here, y is greater than or equal to negative 3x plus 4. I'm going to substitute my test point. I have a x test point of negative 1, and my y value will be a positive 2. So instead of writing y, I'm going to write positive 2 is greater than or equal to negative 3 times, instead of writing x, I'm going to write negative 1 because that's my test point, plus 4. Now I'm just going to solve this out. So 2 is greater than or equal to negative 3 times negative 1 will give you a positive 3 plus 4. And that's going to leave you with 2 is greater than or equal to 3 plus 4, which will give you 7. Well, is 2 greater than 7? No, definitely not. So this just proves that if you pick any point, in this case we did, any point that's outside of the shaded area, it's going to always give you a false statement. So what it means for a point to be included in a solution set, it means that if I substitute those values, it's going to give me a true statement. It's going to give me a true statement. All right, let's do another example here. Let me write this problem down right here. Is 2, negative 1 a part of the solution? Part of the solution in 12x minus 3y greater than or equal to 15. This question is asking us, what is the order pair 2, negative 1 a part of the solution in the inequality 12x minus 3y is greater than or equal to 15? Well, in the last example, our inequality was already solved for y. In this example, it's not solved for y. So the first thing you have to do when you have a problem that's in standard form, you have to solve that equation for y. So you're going to make a cross. And remember, in the previous videos, we talked about cross method. The first step is to change x. That means if you have a positive number, we're going to change that to a negative 12 now. Keep your answer. This case, your answer is 15. Put 15 right here. And keep your y's for your bottom boxes. So your y is going to be a negative 3. I'm going to put negative 3 in both my bottom boxes. Now you have to remember your steps. Your special step, especially for inequalities, if you divide or multiply by a negative number, you have to flip this inequality symbol. So that means when I write my answer here, instead of writing greater than or equal to, because I'm dividing by a -3, my symbol is going to flip. It's going to flip from greater than or equal to less than or equal to. So now my problem is, my answer is y is less than or equal to. Remember, you have to divide from top to bottom. So -12 divided by a -4. I'm just dividing this column right here. -12 divided by, sorry, not -4, -3 will give you a +4. Will give you a +4. You have to put your x behind your slope. And then 15 divided by a -3 will give you a -5. And so since it's a -5, it's just going to be -5. -5. So I have now solved my original inequality for y, and I can now graph this particular inequality here. So let me get some space here. Let me make sure you have this written down. Let me get some space here. And I know that I am trying to figure out if 2 -1 is going to be a part of my solution. So 2 -1 in the solution. That's what we're trying to figure out. We now have our solved inequality for y, which was y is less than or equal to 4x minus 5. Okay, so I'm going to go ahead and I'm going to, let me make my coordinate plane in black. I'm going to go ahead and I'm going to draw me a coordinate plane here, where I have my x-axis and I have my y-axis. Now remember, in your problem over here, you can go ahead and you can pull out, okay, well, I know that -5 is going to be my y-intercept. Okay. I know that 4 is going to be my slope. So since 4 is my slope, I know that my rise over run is going to be equal to 4 divided by 1. I have a positive slope, so I know my graph is going to look something like this. And since my symbol right here is going to be less than or equal to, I know that I'm going to be using a solid line to connect my points, and I know I'm going to be shading below the graph. I'm going to be shading because it's less than, so I'm going to be shading below the graph. So I have a y-intercept of -5, so I'm going to go to the middle of my coordinate plane, and I'm going to count down 5 on the y-axis. So 1, 2, 3, 4, 5. I'm going to put a point at -5. Put a point at -5. Now from there, I have a positive slope, and it's a slope of 4. So I have to rise 4 and run 1. And so since I have a positive slope, I'm going to go up 4. 1, 2, 3, 4. And since it's positive, I'm going to go to the right 1 towards positive numbers on the x-axis. So I'm going to put a point right there. You can do it again. You can make another point by doing the exact opposite. Since this time I went up 4 into the right 1, I'm going to go down 4 into the left 1. So 1, 2, 3, 4, and over to the left 1. Put a point there. Okay. It says that I should make my line solid because of my symbol of or equal to. So I'm going to go ahead and I'm going to connect my dots right there, my points. And I know I'm going to be shading below the graph because it says that it's less than. So anything in this section over here should give me a true statement. That's what that means. It's going to give me a true statement. So from there, I have 2 ways to check this test point. I can graph it like I just did. I just graphed it, and I can actually plot that point. So I'm going to go start in the middle on my coordinate plane. I'm going to go over 2. Sorry, this should be 2, -1. I'm going to go over 2, 1, 2, and down 1 on the y-axis and put a point there. Now, this looks like this is going to be a part of my solution set. So I can go ahead and say yes. 2, -1 is a part of my solution set because it's in the shaded area. But let me show you, remember, let me show you another way that you can check your answer. In your original problem here, y is less than or equal to 4x minus 5. Remember, you have a test point. Of 2, -1, where your test point for x is going to be 2, and your test point for y is a -1. So that means wherever you see a y, you're going to put -1. So -1 is less than or equal to 4 times, instead of writing x, I'm going to substitute my test point x, which is 2, minus 5. Now I'm just going to solve this and see if it gives me a true statement. Negative 1 is less than or equal to 4 times 2 is 8 minus 5. And negative 1 is less than or equal to 3. Well, is negative 1 less than a positive 3? That's indeed a true statement. It is a true statement because negative 1 is smaller than a positive 3. All right. Let's take a look at another example here. Let's take a look at another example. This problem right here is asking us, is 0, 8 a part of the solution in negative 3x minus 6y is less than negative 48. Less than negative 48. Okay. Remember, our inequality here is not already solved for y, so we have to solve it for y by doing the cross method. Change x. If you have a negative number, we're going to make that positive now. So that negative 3 becomes a positive 3. You're going to keep your answer. In this case, it's a negative 48. And you're going to keep your y for both the bottom boxes. In this case, it's going to be a negative 6. Now remember, you're going to be dividing from top to bottom. And since we're dividing by a negative number, we have to remember to flip that inequality symbol. Whenever you write your answer, you have to flip it. So now our answer is going to be y is greater than, because we flipped it because we're dividing by a negative number here. We're dividing by a negative 6, so you have to flip the inequality symbol. So 3 divided by a negative 6 will give you a negative 1/2. Let's take a look at it on the calculator. I haven't done anything on the calculator. So I have I have 3 divided by a negative 6. It's going to give you negative 0.5. I want it in fraction. So hit math, number 1 for fraction, and enter. Is going to convert that to a negative 1/2. So I know that y is going to be greater than a negative 1/2. Have to put your x after your slope. And then a negative 48 divided by a negative 6. Let's go to our calculator here. Negative 48 divided by a negative 6 will give us a positive 8. So since it's positive, it's just going to be plus 8. So now we have our inequality solved for y. We can go ahead and we can graph it. Make sure you have this written down because I am going to erase so I can have space to graph. All right. So let me go ahead and let me get my, I keep doing that, make it black. Go ahead and get my coordinate plane going here. I have my x-axis and I have my y-axis. Have my y-axis up there. We said that our solved equation is y is greater than a negative 1/2 x plus 8. And we have a test point of 0, 8 because we're trying to see if 0, 8 is included in the solution set. So we know that our y-intercept is going to be positive 8. Our y-intercept is positive 8. Our slope is a negative 1/2. So our slope, or our rise over run, will be a negative 1/2. So we're going to rise 1 and we're going to run 2 in this case. So let's go ahead and let's put a point at our y-intercept here. So our y-intercept is going to be positive 8. So start in the middle and count up 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have a point right here at positive 8 on the x-axis. And now I have a negative slope, so I know that my graph should look something like this blue line that I just drew based off of Mr. Slope Man. Should look something like that. And I know that I am going to be using dashes to connect my points because of the inequality symbol. And it's greater than, so I'm going to be shading above. So let's go ahead and let's put some points on this particular graph. So I'm going to rise 1. Since it's a negative slope, I'm going to go towards negative numbers on the x-axis. So I rise 1 into the left 2 spots. 1, 2, put a point there. You can do the exact opposite. I rised 1 the last time and went to the left 2. So now if I go down 1, I'm going to go to the right 2. So go down 1 to the right 2. 1, 2. You can do this over and over again. Down 1 to the right 2. Up 1 to the left 2. To just make you a couple of points. Now from there, since I have a greater than symbol, I'm going to connect my graph using dashes. That just means just make you a couple of dashes. I can't make dashes, so I'm making little dots. Dashes to connect your graph. Now, I have a test point of 0, 8. So, if I were to plot the point 0, 8, I'm going to start in the middle because my x is going to be 0 and my y is going to be 8. So, I'm going to start in the middle and I'm going to count up 8. That's our y-intercept. So, our point is going to be right here on the line, on the graph line. And it's going to be on dashed line. So, what that means is that if your point actually lands on a dashed line, it will not be included in the solution set. That's why we use dashes to tell you that if the point lands on that dashed line, it's not going to be included. If the line would have been solid, then that will denote that it can be included in your solution set. So let's make sense of that here. Let's make sense of that by actually doing the substitution method. If I have my original problem, I'm going to write it. As a matter of fact, let's write it in black. Y is greater than negative 1/2 x plus 8, and I have a test point 0, 8. Wherever I see a y, I'm going to put 8, and wherever I see an x, I'm going to put 0. Okay, so a negative 1/2 times 0 is just 0, so that's going to cancel out to 0. So now I'm left with 8 is greater than 8. Well, is that a true statement? Is 8 greater than 8? Well, no. 8 equals 8. So in this case, this is a false statement because 8 is not greater than 8. And so our graph is correct because remember, if your test point lands on the particular graph line and the graph line is connected with dashed lines, that means that that particular point is not included in the solution set. But anything, since it's greater than, anything in this section right here can be included. Let me give you guys one more example here. Let's say I select this point right here. This point right here, and it's going to be a positive 1, and I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 110. So now I have a test point of positive 1 and 10. If I go over here to my original problem right here, let me erase this. If I go to my original problem right here and I use the substitution method, wherever I see y, I'm going to substitute it with 10 because that's my, I'm sorry, I put the wrong letter there. Because that is my test point. 10 is my test point for my y and 1 is my test point for my x. And this is giving me the blues right now. Okay. It's not letting me write it here, so as a matter of fact, let me just write. My test point is 110, where 1 is my test point for my x and 10 is my test point for my y. So wherever I see a y, I'm going to put 10. So 10 is greater than negative 1 divided by 2 times 1. Wherever I see an x, I'm going to substitute my test point 1 plus 8. And now I'm just going to solve that out. So I have 10 is greater than a negative 1 divided by 2 times 1 will just give you negative 1 over 2 plus 8. Plus 8. Now let's say you don't know what that is. Let's go to our calculator right here. Negative 1 divided by 2 plus 8. It's going to give you a decimal, 7.5. Remember, convert it to fraction. Math. Well, you know what, as a matter of fact, in this case, test points, don't convert to fraction. Leave it as a decimal. So I have 10 is greater than 7.5. Well, is 10 greater than 7? That is indeed true. And if you see right here, our test point was inside of the shaded area. So this proves again that if you pick a point inside the shaded area, it will always give you a true statement for your solution.